Good morning. This is part 2 of our lesson on solving equations that involve fractions. This morning's lesson will involve instruction on solving equations that require addition and subtraction of fractions. Okay, so here's the title that you should have on your practice set of problems. Today's date, solving equations with fractions, addition and subtraction is in parentheses because those are the operations that we're targeting through this morning's problems. Once again, I'm going to model and explain how you should have solved some of your problems from last night's practice, buddy, and then I'll give you a math problem of the day to test out how well you're able to do this independently. Those of us that answer the question or respond to the problem correctly, you'll be free to start tonight's practice buddy assignment. Those of us that don't respond correctly, I'll just pull you to the back table for some additional help. Full questions for now. One of the things that I want to focus on with you today is labeling the numbers on your paper. Because when you take the Park assessment, I'm not sure if you remember this from last year or the last times that you took the Park assessment. With the math problems, not only did you have to solve the computation portion of the problem, so you had to do the actual operations, the solving portion, but you also had to explain what you did to get your answer. And in some cases, I don't know if this was true for 5th grade, but for 6th graders, we definitely have had problems where you have to literally explain what the numbers are that you have written on your paper. So that's what we're going to practice doing today. Are there any questions about what I just said? Okay, yes? So today, I've wised up a little bit. I've already written down the 3 problems that we're going to explore, so I won't need any help from you guys today. All right, so number 1. Time with problem number 1. We have 15 is equal to x plus 1/3. Now, you don't need a Chromebook. You don't need any paper outside of your math notebook. You do need something to write with, and you should be copying everything that I have on the board. Preferably, I hope that you have a pencil. If not, you can use a pen. We're refraining from asking questions or interjecting any kind of noise until we're done with the problem, and then we'll go back and ask clarifying questions that help us understand what I've written on the board. Okay? All right, so through this problem, we see that we have a whole number and we have a fraction. We also can tell that the operation in the problem is clearly addition, right? Yes, and so what we've learned about solving equations so far is that, number 1, our goal is to isolate the variable, get it by itself so we can see what it's equal to or what its value is. And number 2, in order to isolate the variable, you have to do the inverse of the operation in the problem. So everybody's going to say it together with me. What's the inverse of addition?
Subtraction.
Subtraction is the inverse. Okay. Now, by show of hands, which number do I have to take out of the equation in order to isolate the variable? Kennedy. We have to get rid of 1/3. Okay, Tamia, what is the first thing you would do to this problem to isolate x? Yes, what's another way to say take away 1/3? Tyree.
Subtract 1/3.
So what I'm hearing you say is that you would subtract 1/3 from both sides of the equation, the left side and the right side, correct? Yes, so let's do that. We're going to take 1/3 from this side, and we're going to say minus 1/3 from this side. Make sure you've written this down quickly and with me. As I write, you write. That's the way you keep up. Now, on the right side of the problem, and by the way, in the future, try to make sure you have a pencil and maybe some kind of colored pen or something else. I know typically we don't use markers or pens in math, but just the same way I'm highlighting what I'm doing to the problem, I'd like for you to do this too. That way you can see what you did to the equation to solve for whatever the variable is. Okay, so on the right side, we can see that through these inverse operations, the 1/3 on this side have canceled each other out, right? So they're no longer in the problem, we're just left with x. X is going to be equal to the answer to 15 minus 1/3. Okay, so let me write that correctly. 15 minus 1/3. Now, I'm going to take a little break. At this point, I'm going to step away, not literally, but just take a step back for just a second, and I want you to turn and talk. Turn and talk to the person beside you and tell that person or talk with that person about what you would do next. Our goal is to figure out the value of x. What would you do next in this case? I see he's making an effort to be involved. So if you just include him, I think you're good. And then if you take down superior, then good, I'm hearing some good conversation, so let's bring this back whole group. Whole group. Okay, did you want one more second to continue talking? Okay, so what I heard some people saying is that, number one, you're going to have to do some borrowing. And you'll have to borrow from 15. Remember this morning we discussed how these numbers like 15 are whole numbers and fractions are actually part of a whole number. So what you have to do first, well, let me ask, what do you do first? Let's see. Isaiah. Yeah, so I'm going to borrow a 1 from the 15. I'll cross that out and make it a 14. Caleb, what do I do next?
Next, you'll try to subtract 1/3 from 1, but you can't, so you turn 1 whole into a fraction.
Right, good clarifying point. So I borrowed 1 from the 15. That became 14 because I took 1 away. I literally pulled out this 1. I can't take 1/3 away from 1. So what did you say I had to do? I had to convert 1 to a fraction. How do I do that, Mikhail?
Make the denominator whole.
What do I look at down here to help me decide what to make the denominator? Ricardo. 3. Since this is already a denominator of 3, I make the fraction above also have a denominator of 3. What should my numerator be? It should be 3 as well, because when I write a fraction in this format, it's equal to 1, correct?
Yeah.
Yes. Good job, guys. You remembered something. I could almost do a cartwheel. Good job.
Don't hurt yourself.
Okay, I won't hurt myself. Let's keep going. All right. So now that I have a fraction up here, I can actually do my subtraction, correct?
Yes.
Yes. Antoinette, what should I do next? Leilani, what should I do next?
Subtract
What am I subtracting? Use your words carefully.
3/3 minus 1/3.
But am I subtracting the bottom numbers?
Well, you're keeping them the same.
I'm keeping them the same, and so I actually only subtract, what's the name, what part of the fraction? Tamia? The numerators. I only want to consider the numerator, so I'm going to subtract this numerator. I'm sorry. I'm going to take 1 away from this numerator. So 3 minus 1 leaves me with 2. I never ever subtract the denominators when I'm adding or subtracting, so the denominators stay the same. Hold the question for just 1 second, okay? And I have nothing to take the 14 away from, so it stays the same. And so now my answer is 14 and 2/3 is equal to x, correct?
Yes.
Yes. Does anybody have questions about this? No? Okay. add a new page. That was fairly easy, right? See, the more we do these, the easier they'll get. And I'm almost sorry that Aliyah is not here because she hopefully would become, through this lesson she'd be getting more familiar with fractions and more comfortable. I'll post our video lesson on the Google Classroom as well. Alright, so the next problem, and I skipped number 2 because it's fairly easy. We'll do the challenging and come back to the most difficult. We'll do the challenging first and then go to the easiest. Alright, stay with me. Staying on task and target. Remember, we have to limit our conversations so that we can learn what we're supposed to learn. Copy the problem down. We completely solved this one, so this needs to be solved on your paper at some point. At this point right here now, though, you need to fast forward to number 3 so you can keep up with us as far as that one is concerned. Okay, I'm going to have you turn and talk again. If you'd like to turn and talk to a different neighbor this time, that's fine. Here's what I want you to talk about. Number 1, what do you notice about the problem? Number 2, what would you do first to begin solving the problem, and why?
I noticed they had to get two big ones. So what is the greatest combination?
Girls, why don't you trade places? Why don't you specifically divide that way? You don't have somebody to talk to. So we can be involved. You too. Come on, Dan.
No, you can buy.
What would we be doing first?
So you can multiply 8 plus 6. So you have
Division. Why? What's the operation? And do you notice anything about the fractions themselves? Yeah, our mixed numbers. You notice anything about the fractions? That's not appropriate. This is but not right now. What did you guys notice about the problems? They have whole numbers. Fractions and whole numbers are called mixed numbers. Do you notice anything about the denominators? They're different. What do you need to do when the denominators are different? Simplify. Okay, I heard some good conversations. Let me tell you what I heard. I heard somebody say the first thing they noticed is that these denominators are different, which means before you can do anything with them, compute them in any way, you have to find common denominators. I heard some people say that they noticed the problem involved mixed numbers. And I heard some people talk about the fact that because addition is the operation in the problem, we needed to do the inverse or subtract to figure out what m is equal to. So that's actually what we're going to do. If we consider this problem, the one number, Tyreek, that we need to get rid of or delete from this equation to figure out or to isolate m is what? What number do we need to get rid of to isolate the letter m? 4 3/4, right? All right. So because I'm adding, I'm going to subtract the very number that I need to get rid of from both sides. Let's do this together. And notice I'm switching my colors. Let's remain quiet. And let's make sure we're copying everything down that I have on the board. When I'm copying it so you don't fall behind. Because I will be moving on in a second. Just flip to another sheet of paper. Alright. On the right side of the equation, these two mixed numbers have canceled each other out because of the inverse operation. So that's what I'm going to indicate through my line. On the right side, the only thing that is left over is M. On the left side, though, I now have this problem. 8 1/6 minus 4 3/4. Like this. Now, typically, if the denominators were exactly the same, I could go ahead and do the easy subtraction. But because they are different, I can't do that just yet. I have to find a common denominator. I have to make those denominators speak the same language before I can subtract them. Hold all questions until we're completely done with comments as well. Okay? That way we can stay on track. Okay. So what I need to do is to find a common denominator or a common multiple for 4 and 6. So I'm going to use this good old method of finding least common multiple. I'm start with 4, then I'm going to go to 6. What I'm doing here and now is listing the multiples, right? I'm finding all of the products of 4 and then for 6. So 4 times 1, help me out. 4 times 2,
8.
4 times 3,
12.
4 times 4. Okay, now I'm going to stop here because I noticed that 12 is a multiple of 4. It's also a multiple of 6, right? Yeah. Okay, let's see. So 6 times 1 is, and then 6 times 2, 12. So I've already identified the least common multiple, which means that this number, 12, is now going to become my common denominator. Alright, so I need to rewrite the problem. And I'm rewriting it like this. 8 1/6, and you have to keep it together. I see some people falling apart a little bit and singing and humming and talking. You don't want to do that because it causes a distraction to other people. So minus, I'm aware of that, Tyreek. I'll be out of your way in one moment. Here you are. Good, I see somebody picked up my idea of changing the colors already. Nice job. You do not right now because you didn't know to have different colors, but I would like to do it in the future. It makes it easier to see the changes that have been made to the original problem. Okay, so we know that our least common denominator is going to be 12. We already figured that out because it's the LCM. And let me label this as LCM. So now to figure out the to figure out the numerators, we have to compare and contrast the old denominator with the new denominator. So how do we get from 4 to 12? I have to multiply by 3. Whatever you do to the bottom, you have to also do to the top. So 3 times 3 is 9. Mikkel, how do I go from 6 to 12? I have to multiply by 2. Whatever I did to the bottom, I also have to do to the top. And now we have, there's a commercial that my daughter loves. There's a little guy in the bathroom and can't get his belt off, and he says, "Mom, we have a situation." Okay. So we have a situation here, but it's nothing we can't handle, and I'm glad I picked this problem to model for you. Look, we've got our fractions to speak the same language, they have the same denominator, but this is a problem that's calling for subtraction, and this is the most critical or crucial time to listen. If you look at the numerators, which are the only two things that we're going to actually subtract, this is a rhetorical question. What do you notice about the numerators? Not denominators, numerators. That is the 2 is smaller than 9, which means I can't take 9 away from 2. Turn and talk to your neighbor. What are you going to do to remedy this problem?
No, you were trying to make T greater than 9. But how about with you borrow from mine?
How?
Oh, the whole number 8.
Okay. I'm curious, how are you going to remedy this little problem of not having enough in the numerator up top?
Switch 9 over to
Well, you can't really do that. You can't do that. What would you do instead, Charity? Borrow from what? Borrow from this 9? No, you can't borrow from that 9. You owe this 9. Like I have only $2 and I owe you $9, so I can't go back and take $1 from you, otherwise I'll owe you more. Zach, I haven't heard from Zach. What number are you gonna borrow from? I have to borrow from the 8. And that's exactly what I'm gonna do. So pay attention, people. I'm switching my colors so you can see the borrowing. Focus, 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 focus. Okay, Mikhail, are you with me? Alright, so I'm going way over to the 8 and I'm borrowing 1. The 8 now becomes 7. So notice I'm borrowing a 1 that I want to add to the 12, right? I have to add 2 12ths to 1. Can I do that?
Yes.
You can add 1 to 2 12ths? I can take a whole number and I can take a whole number and add it to a fraction?
No.
No, what do I have to do? I have to turn the whole number into a fraction, which is what we just spoke about in the problem above. So I'm going to do this. I'm going to say, I already have a denominator of 12 going, right? So I'm going to make 12 this new, see, again, I'm trying to convert 1, the whole number, into fraction form. So I'm going to take 12 and make 12 my numerator, and by writing 12 over 12, I have 1. That's this 1. It changed forms. It went to fraction form. Yes, it equals 1 whole. And now, if I add, see, I just regrouped this 1. I pulled it out and regrouped it to this fraction, but I have to regroup in fraction form. When I combine these two, then I'll have enough to take the 9 12ths away from. Hopefully you have more room than I do. So if we add 12 plus 2, we end up with actually 14, right? And 14 12ths, because that stays the same. It's getting a little hairy, right? Hairy. Hairy means, these are rhetorical questions, meaning it's a little difficult to follow. Bad choice of words. All right, so now, let me rewrite this so it's nice and neat and clean. What I'm doing now is I'm taking 14 12ths, and then I'm going to subtract 9 12ths. It does not matter at this point that this is an improper fraction. The only thing that does matter is the fact that this 14 is big enough for me to subtract 9 from. Clarifying question?
So, if you try to subtract a fraction that value is negative, you have to turn it to an imperfect fraction?
Wait, so ask it one more time.
So if you had,
I had this fraction and the numerator was too small.
and you have to turn it into an imperfect fraction to subtract.
No, what I do have to do is I always have to borrow from the whole number. Borrowing from the whole number will not always result in this improper fraction. That's just how it ended up this case. But in answer to your question, if this number is too small for me to subtract this, I always have to borrow. It's no different from this. It's no different from this kind of subtraction problem. If I don't have enough here, I'm always going to have to borrow. Some of us are off task, severely off task, and And while I know this is a challenging problem, you have to force yourself to be attentive, engaged, and in the moment. Because soon we're going to have a quiz on this. And if you don't have a good set of notes, you will be completely lost. All right. So let's continue. We're still trying to figure out what M is equal to. This just got transformed into this, and now this. Remember to raise your hand. I'll say it one more time. 8 and 1/6 has now become 14 over 12 minus 9/12. Okay. Now we can easily subtract. 14 minus 9 is 5, right? 5/12. Well, we're not quite done with the problem. Here's what I forgot to write in. We still have the 7 from the 14/12 and the 4. So let me put this in as well. All right, let me erase this and let's look at this again. Remember, please refrain from blurting out. It doesn't help or benefit anybody. Okay, 14 minus 9 gave us 5. The denominator stayed the same. 7, take away 4 is 3. So now we know that M is going to be equal to 3 and 5/12. This was a very long problem, yes? Okay. So let's go back and review what we did, and then I'll give you just a chance to ask questions, and then we still have to label. All right. Wait for just a second. I'll stop at the end and let you catch up to wherever you left off at. So 8 and 1/6 is equal to 4 and 3/4. We isolated M by subtracting 4 and 3/4 from both sides. So let's actually label that now. Can we? Draw an arrow and say that, what do we want to say? We want to say, we isolated M by subtracting 4 and 3/4 from both sides. Has anybody seen Hidden Figures yet?
Yeah.
This is kind of what she was doing, right? These long calculations. So again, we're labeling the numbers. We're saying that we isolated M by subtracting 4 and 3/4 from both sides. I think we're going to put our work in the hallway too to show what a wonderful job we're doing and what challenging and involved math problems we're solving. Not, oh my gosh, not even with calculators, right? Woo! We did this all with the calculators of our mind, and I bet you probably didn't even think you could do that.
Nope.
Yes, you do. You're going to demonstrate it in just a minute. All right, so we did this. Sit down and stay on task, okay? We're not talking in sidebar conversations. We were left over with this. We've already labeled these numbers and said that this was fine when these common multiple. I'm going to go easy on you. And I just want us to circle these, and we're going to label these our equivalent fractions, okay? Oh my goodness. Time flies when you have fun, right?
Yes.
Look what time it is.
Yay.
Yes, this is fun.
How?
All right, label that equivalent fraction so you know here was our original fraction and here's the equivalent fraction. I have to get in this math POD before we leave. So here's your math problem of the day. It's going to tell me who I need to help more later on. We should be good to go with tonight's practice buddy because you're taking these sample problems home and using them as examples. All right, here's the math problem of the day. Whether the bell going to continue working until we finish, okay?
Do we need to work it all out?
Yes, sir. You are not blurting out. Okay, here's the problem that I skipped and came back to. Remember, label this math POZ. Okay, turn and talk. What do you notice about this problem? What's the first thing you would do to solve it? We gotta multiply. If you want, you can go in.
Oh, I mean, but I'm still done. We already have
No, I didn't say start. Here's what I said. Look, you see what you noticed, and tell your partner what you would do first. But now go ahead and start.
I would do